So I'm here to just give you an introductory overview so that we can put some of the presentations which follow into a little bit of context. So Model Code 2020 is all about enabling advancements in the construction of new materials, in new structures, and the management of existing concrete structures. That didn't work. Yeah, I'm pressing that button. Anyway, so today's about, as I say, providing an overview of some aspects, not all aspects of the Model Code. Clearly, all engineering works are undertaken to establish or meet established societal needs and goals. And accordingly, Model Code 2020 takes sustainability as a fundamental and overarching consideration for the design of new structures and the management of existing ones. So a key aspect of the framing of the code relates to sustainable decision-making based upon the three-pillar concept. As you can see here, social, economic, and environmental. And the integration of these approaches to design, execution, and life cycle management. You have to press twice all the time, I think. Anyway, so to try and bring the complexity of the process which was described in the text of the code, we've sought to represent this in a flow chart. So if we start up here, top right, the initial considerations relate to societal sustainability, and they link into owners and stakeholders' sustainability, performance and outcome-based requirements taken under social, environmental, and economic heads. So we call this, in a performance-based situation, like the tier one operational and stakeholder interpreted requirements. And then these feed through to this box over here. So the blue lines are the main flow, and the green lines seek to represent feedback loops. So then these requirements are decomposed into the relevant parts of the organizations and bodies in the supply chain. So in this example, it's designers and people who create the technical scheme and specifications, contractor, materials manufacturers, and there may well be more tiers. And this slide here, underneath that one, just expands and shows these concepts in more detail about the way they're decomposed and then brought forward into the conceptual design process. So Akio, in his presentation, showed the same sort of process. And then we drop down into this life cycle management activity, which involves design and redesign, execution, commissioning. So that then leads into conservation of the structures, assessment as required, and interventions as necessary. But of course, that eventually drops down to end of life, maybe decommissioning, which might be deconstruction and reuse or demolition. But of course, this is the end of one cycle and perhaps the beginning of another with the circularity of resources. But there's also aspects related to the specification of materials and execution processes and so on. And then these are the idea is that these evolve in an iterative manner to check back and verify that the performance requirements have been met through an appropriate verification process. So drawing this out into a bit more detail and quoting some of the texts, this represents the first part of the process where we've got the definition of performance-based requirements. This sort of indicates a number of the chapters which it interacts with, which we deal with. But I'll not dwell on this because Agnieszka will explain this in a later presentation. And then, of course, that process of defining the requirements is then evaluated and replied to via a performance evaluation methodology. So by models, by testing, other validation procedures. So you're checking the conformity by models or by testing. You may use design by avoidance. You may use deemed to satisfy rules in appropriate circumstances. Of course, we started with Model Code 2010, which was 5 parts, 10 chapters, and about 400 pages. Because of the increasing complexity of the situation that we find with Model Code 2020, which is dealing with new build, as was Model Code 2010, but it's expanded to existing structures because it's dealing with the entire life, through life, management of structures. And of course, we also need to take into account, oh, what's happened here? Hello at the back? Is it me? Thanks. And of course, there's a lot of, is this Pit? Sorry. I see what I'm doing. Too many buttons. So we've also got to take into account the technical developments which have occurred since Model Code 2010 was published. So that's resulted in 10 parts, 39 chapters, and the current draft's about 1,100 pages. To reduce the page count and provide supporting information, there are additional supporting bulletins being developed as the work proceeds. But let me just say a little bit about the actual table of contents and the structure of the code. So part 1, up the top here, chapters 1 and 2, terminology. Part 2 is basic principles. So this relates to sustainability, the performance-based approach, principles of life cycle management, principles of design, assessment, execution, conservation, circularity and dismantlement, and of course, quality and information management. So that's laying out all the basic principles which are applied in the code. And then part 3 here starts with the principles of structural verification in terms of structural performance and the principles of structural design and assessment. Then moving on to part 4, this is a new section in the code. It deals with actions on structures. Then part 5, as similar to Model Code 2010, input data for materials. So we've got a range of concretes, reinforcing steels, pre-stressing steels and systems, non-metallic reinforcement, fibre reinforcement, UHPC, and of course, with existing structures, you need protected materials and systems. And then part 6, input data for interfaces, so more materials, more interfaces. So chapters 20 to 25 deal with embedded steel, embedded non-metallic reinforcement, externally applied reinforcement, obviously concrete, new concrete to old concrete, and then concrete to steel by mechanical interlock, so structural sections, and then anchorages in concrete. Moving on, part 7 deals with design and assessment. So this is the main technical content of the code, chapters 26 to 34. And you can see here, so we've got conceptual approach to design and assessment, then the approach to design, approach to assessment, and then structural analysis, and then the really major content of the code in terms of technical information is this section here, chapter 30 on structural performance verification. And then evaluation of other aspects of social performance, environmental quality, environmental efficiency, and then trying to bring all this together in terms of making a sustainable decision about the candidate solutions you have for your scheme or your intervention upon the structure. And then part 8, execution, so management of that, and then consideration of construction works and execution of interventions. And then finally, we have part 9, which is conservation, i.e. life cycle management in Model Code 2020 speak. And then part 9 deals with circularity and dismantlement. And there's, as I say, an associated program of supporting bulletins, which are importantly being developed at the same time as the code. Okay. There we go. 3 presses that time. So this makes a comparison between Model Code 2020 and Model Code 2010. And as I said, the main technical content is in this section here. So this is a page count. for the technical content in both, and the percentage contribution to the total document. So you can see really the big growth in the length of the document comes in these sections just because of the sheer volume of new information. And then the technical content summarized here, and you need a front end and a back end, so the few pages. But this isn't quite a fair comparison because this is a professionally edited hardback copy. So I think when we sent them the text as a Word file, this was probably about 550 pages, so that they edited it down. So it's about double the length as to the Model Code 2010. How are we doing for time? So I've classed this as an aspirational program. So we've done those parts. So output 1, as we've termed it. So that's a full version of the author drafts. They've been compiled and partly harmonized and distributed for comments. And we've had the comments back from that, or having the comments back from that, which will enable us to derive a second complete version. But essentially, the difference is that it should be, or we're aiming for it to be, largely harmonized. So again, output 2, it's digital, be available to task group 10.1 and other parties. And then in the winter, so at the end of this year and early next year, we will hopefully have received the comments on that document, and we'll prepare the next edition, which will be called the pre-publication draft. Again, we're envisaging that to be digital, and then that will lead us to a final draft, which will be presented for voting by the General Assembly in summer of next year, we hope. And that then leads us to the final goal, the publication, which I understand we will be passing on to the printer, to the publisher. And it's, oh dear. Thank you. And we're considering a hardback, digital, and what's termed a digital plus set of versions. So nothing's fixed yet, but looking to the future, maybe a digital plus where you've got, say, interactive links, may be a possibility for us. Then the concluding comments. Model Code 2020. What's going on? So it's providing improved technical guidance for the design of new structures and the assessment, adaptation, conservation of existing structures. So these capabilities, combined with the improved ability to undertake appropriate interventions upon deteriorated structures, are critical to extending the useful life of concrete structures and upgrading them to satisfy existing or revised increased performance requirements, but hopefully at a low carbon footprint level. So summarising, it's hoped that the Model Code 2020 innovations and improvements can assist with the creation of durable low concrete carbon structures and provide better tools and techniques for the design of new structures and the assessment adaptation of existing ones. And clearly their goal is to have a new version of the Model Code which is better suited to the future demands and circumstances to be encountered in the challenging years ahead as we try and move towards net zero. So I'll stop there.
Thank you, Stuart. I hope this gave you the sneak preview of the content, overall content of the model code, and I suppose that there will be some questions. We, in the meantime, have a microphone, so if somebody wants to ask Stuart anything based on his presentation, please do so.
They're all,
yes,
no,
please.
they're not all happy. You don't necessarily get the same information on that screen as you do in this one. It gets confused.
Thanks a lot for the presentation.
Okay.
It is clear that repair and retrofit is an important issue for existing buildings. Do we have some new technology, low carbon emission repair materials? Because we have a lot of existing structures. Secondly, do we have some modeling approaches, analysis approaches for substandard structures which are repaired with this kind of new
Well-
low carbon materials?
We're not prescribing any particular material. We're just seeking to put in place ways in which you may be able to use materials coming on. So we're trying to make sure that the code is not a barrier to change by seeking to adopt performance-based approaches. And there are some lectures coming up. Lecture 7 and lecture 11, or paper 11, talk about evaluation and assessment of existing structures. And paper 14 deals with conservation and intervention. So hopefully we'll provide a bit more information as we go through the day. But if not, come and see me and we'll see if we can provide you any additional information.
Okay, thanks a lot.
If next questions are
How are we
there,
for time?
then thank you, Stuart.